Hello there, I am S and this is S Solution. We'll be looking at algorithm questions and this will be the first in the series. And we have done a JavaScript series, just a brief series on introductory JavaScript, just so that it could help us when we are writing the code out for our algorithms. That was just basically it. It's nothing deep, it's nothing in depth, just surface. And I hope you could check it out if you are new to programming. It could help you in that. Now, in this video, we'll be looking at the staircase algorithm question, and I hope you do like this. If you like algorithms, you are into algorithms, and you're someone that likes thinking critically, these algorithm questions, we push your brain, and hopefully will make you think broader in the future. If you're into such things, please like, share, and subscribe. Let's get in the video. So the question says, there exists a staircase with n steps. You can either climb up either one step or two steps at a given time. So at every point, I can go one or two steps. Now, given n, where n is the number of steps, so we are going to be giving n. We should write a function that returns the number of unique ways you can climb a staircase. So, for example, when we have a staircase of 4 steps, so a staircase has 4 steps. It's telling us that then we will have 5 unique ways of something. So you see, when our number of steps is 4, we have 5 unique ways. That is, you can either go one step, one step, one step, one step to the first one, or you could go 2 steps, then one step, or you could take one step, then 2 steps, then one step, or you could take one step, and then 2 steps, or you could take 2 steps and 2 steps. So there are 5 ways we can use to get to the 4th step from the ground. Now let me try to illustrate that. So here we have our staircase. So 1 step, 2, 3, and 4. So if we remember, I think the first is we have 1, 1, 1, 1. We have 1, 2, 1. We have 1, 1, 2. We have 2, 1, and we have 2, 2. These are the 5 unique ways. So let's just look at it one by one. So we have, if I can go 1, 1, 1, 1. That's 1. We could go 1, 2, 1. We could go 1, 1, then 2. So we could also go 2. Sorry, okay, something wrong. Okay, so this should have been 2, 1, 1. Sorry, this is 2, 1, 1. So we could either go 2, 1, and then 1, or we could go 2 and 2. So these are the 5 paths through which we can get to that step. 5 unique ways of getting to that step. Now, let me push this here, and so it means that if we have our staircase, so let's say we start from here. We are starting from the floor, right? So from here, you notice you can either take 1 step or you take 2 steps at this point. Now, if you come to this point also, you can either take 1 step or you could take 2 steps. So you see, at every point, you can either decide to take 1 step or you decide to take 2 steps. That is very important for us. So we either take 1 step or 2 steps, and then we continue going until we have reached the top. That is the number of steps. So step 4, this is step 3, this is step 2, and this is step 1. So we continue until we have reached step 4. So at every point, we can either take 1 or 2 steps, 1 or 2 steps, 1 or 2 steps at every point we keep getting to. So let's put this together and see how we can solve this in our algorithm. So we have the process is that at every point I could either take a step or 2 steps. So let's look at this in code. So I have my function staircase count, and we want to write the algorithm out now. So at every point, so remember, at our we start from 0. This is staircase 0, no stair, and at this point we could either take 1 or 2 steps. Now when it landed in step 1, we could also either take 1 or 2 steps. And if you look at when it lands in step 2, we can either only take 1 step or we take 2 steps. So at every point, starting from 0, we can either take 1 or 2 steps until we reach our last step. So when we reach the highest step, we know we have, that's it for each approach. Okay, so let's look at this now. Let me try to give this. So it means we are starting at 0. So at 0, at staircase 0, I could either take 1 step or I could take 2 steps at point 0. Now at point 1, at step 1, I know that I can either take 1 or 2. So 1, so I add a 1 to it, or I could take 2. At point 2, I know I can either take 1 step, I could take 2 steps. Now note that this is equals to 4. So we know that we stop at this point for this. Is equals to 4. So we know we have 1 count. So we go on. Let me go back to it. So at this point also, we know we can either take 1 step or we could take 2 steps at this point. And for this also, it means that we have reached a point that is equal to 4. So this is another one. So this is my number 2. So I come here. This I can either take 1 step or I can take 2 steps. Now if you look at 212, 212 is more than 5, so we know that it's out of bounds. So this is not it, so that is out of it. So let's go back again. We at this point I can either take 1 step or I could take 2 steps. 1 1 1 2. But same, this is 5, so I know that is out of it. So okay, and 1 is 4, is equal to 4, so I know that I've reached. So this is, so I have 1 there. This is also 4 already, so I have another 1 here. Okay, we skipped 1 here earlier, so let's go back to that one. So here I could either go 1 step, that is 1 2 1, or I could go 1 2 2. Now this 1 2 2 is already beyond 4, is at 5, so we know that this is not legible. So but 1 2 1 is equals to 4, so it's 4. So this is another. So you see, I have exhausted. There is no other possibility now. Every other is either it is cancelled out or it is fulfilled. So if it's more than 4, there's no point going further. We know we have reached an end point. And if it's equals to 4, we have also reached an end point. So we have 1, we have 1, we have 2, we have 3, we have 4, and we have 5. So there are 2 approaches that we use. Maybe I'll divide the video into 2 so that and if we could finish everything in this video, that would be good. So the first approach will be using this, where I could basically create an array. I will create an array. For example, at the beginning it will have 1 or 2 steps, and then it will go through it. It will go to the next and say, okay, 1 for this first one. There are 2 possibilities. It's either it goes 1 1 or it goes 1, 2. And don't forget we have this 2 here. So we can pick the 2. We know that, so this will be 1, 1, 1, 2. So when we pick the 2, so we pick this 2. For 2, we know that, okay, there are 2 possibilities for 2 also. Is either we go 2, 1, or we go 2, 2. So at each point we are asking, is 1 plus 1 equals to 4? No. Is 1 plus 2 equals to 4? No. Is 2 plus 1 equals to 4? No. Is 2 plus 2 greater than or equals to 4? Yes, 2 plus 2 is greater than or equals to 4. It is equals to 4 as a matter of fact. So we know we are okay with this. Okay, so let's just continue. So we can go again. We ask ourselves, we can pick this 1, 1. So 1, 1 has the possibility of either 1, 1 or 1, 1, 2. This also, so if I were basically to come and do this, this will also have a 1, 2, 1 or 1, 2, 2. Now 1, 2, 2, it will not take this. Since it's more than 5, we can remove it. I mean, it's more than 4, we can remove it, knowing that it has to be 4. So we can go on to this 2, 1. 2, 1 could be 2, 1, 1 or 2, 1, 2. Now this 2, 1, 2 is also more than, so we can cancel it out. And we can go to 2, 2. So 2, 2 is already at 2, 2, so we could. So let's go over it again. So 1, 1, 1, 1, 1, 1. This is what 1, 1, 1 has 2 possibilities again. 1, 1, 1, 1 or 1, 1, 1, 1, 2. Now this is beyond 4, so to cancel this. So we go here. This is already 4, so there's nothing. We don't need to do anything. This is already 4. This is already 4. This is already 4. And this is already 4. So let's come again. Is there any? This is 4. 1. This is 4. This is 4. This is 4. And this is 4. There's nothing. Everything is equal to 4. And so we have. So if we were to count it, if we want to count how many items we have here, 1, 2, 3, 4, 5. That would be my first approach. So let's put this in code and see how this is going to come out. So you remember we start from step 0. So we have our array. So let's just create steps array. Steps array. So we have an array, and we know at the beginning our array will be, at the beginning you can either take 1 or 2 steps. So we can have step array, or basically we can do that at this beginning. We know it will either at the beginning to have 1 or 2 steps. At the beginning it either starts with 1 or with 2 steps. So we have to move forward from this now, either 1 or 2 steps. So how do we go from this? So we continue the, if you look at, if I were to show us our algorithm question again, we continued our iteration. We continued until everything summed up to be our 4, which was the number of steps. So we can say, so so let's just go with this. So steps. So while we want to continue while the steps array, while all the items in steps array, while they are not equals to 4. Okay, so how do we go about this? So we could basically do this. Sorry. We could basically do this whenever we reach our sum, whenever we reach our number. So for instance, when we reach here, we could just say this is 4. We could just say this is 4. We could just say this is 4, 4. So basically at this point we have changed this to 4. At this point this will have been 4, and this will have been also 4. This will have been 4 here. So we continue until everything is 4, which is the number of steps. Okay, so based on that, now we could just say so we have marks and say let the steps math.marks. Now math.marks is basically, sorry, math.me. I will explain this right away in 1 second. So what I'm doing here basically here is this. I'm saying that okay, I want to know the minimum. So if I were to come here, sorry, if I were to come here, and so basically what I could do is okay. So this is the sum of this is 2. So I could do it. I could make this based on the sum. Yes. So rather than writing 1 1 1, what I could do is this is 1 1 is actually 2. This is 1 2, which is actually 3, and this is 2. I could make this is 2, this is 3, this is 3, and this is 4. I could make this is 1 1 1, which is 3, 1 1 2, this is 4, this is 4, this is 4. So I could basically do this. So it means that I will continue until everything is 4. So at that point, the minimum thing, which is 4, when it's at this point, the minimum is 2. But at this point, the minimum is what? Is 4. Everything here is at least 4. So it's 4. It's not greater than 4. It's not less than 4. The minimum is 4 here. But at this point, the minimum is 2. The maximum is 3. At this point, the minimum is 2, but the maximum is 4. So we can't use. That's why I change it from max, because I know that one number there will be a first point where we get to our maximum step already. So I want to continue until all of them. So it is only at this point I will have the minimum to be equal to the number of steps. So if I come here, so basically what this is a spread operator. What the spread operator does is it checks and see, okay, so if I were to show us what is inside max, now max will be 1, because between 1 and 2 the minimum is 1. So that's basically so I want to continue this while the max, or rather since y is mean, it should be mean, while the mean is not equals to the steps. Let me make this mean. Don't forget, steps in this is 4. So I like to put this so that, so while our mean is not equals to 4, we continue this. So if we go back to this, so while we continue from here, our mean was not 4, we continued. Our mean here was 2, our mean here was 3, but our mean here was 4. So we continue until the minimum value we can get is what? 4. So let's go back again. So permit me to comment this out. So I can remove this break. Okay. So at this point now, I am saying that while my minimum steps is not equals to, while the minimum value in my array is not equals to 4, for example, in our example case is not 4, we continue doing this. So what are we doing continuously? We are adding 1 or 2 to each of the values there. So for example, we pick the first value. So we can see steps array dot pop, and if you remember this, so if you remember this now, so you see what we are doing basically is we are saying, okay, remove the last item. So in this case is 2. So if so what do I want to do? There are 2 things I want to do. I say I add 1 to it and I add 2 to it. So remember, if we go back to our whiteboard, so we either add, so for each of the steps we either add 1 or we add 2. So 1 plus 1, this will give us 2. This 1 plus 2, this will give us 3. 1 plus, so when we come here, 2 plus 1 gives us 3. 2 plus 2 gives us 4. So we keep, so at every, for each of them we are either adding 1 or 2. For these two, we are either adding 1 or we are adding 2. So I'm adding 1 or I'm adding 2. So I could say at the first so I'm adding 1, and then we have when we are adding when we're adding 2. So, but you remember, if we have reached a point where we have 4, so if uh if my value is equals to the number of steps already, there's no point. So it means that is valid already. If it's equals to the number of value, so what do? I just move on. I say okay. So I want to put it back into our array. So I could say on shift, and I put it back. So I could say val. But else, if it is not equals to, that is when I want to do all of this. So let's see. So I want to get the sum of the first. So I want to see if the first is not equals to, if it is equals to 4, the steps here now. If it's equals to the steps, that means I found one. If it's equals, or let me just come here and say, if it is less than or equals to the steps, we are good with that. So if it is less than or equals to steps, what do? We add it. We add, or we add it. And the same thing if the second is also less than or equals to steps. Steps array dot push second. So let's look at this again. Why am I using on shift here? Is because I want to add it to the front. I'm getting my value from, pop will take it from the back. So I want to be getting my value from back, but when I've reached a place where I've gotten a value that is already 4, I want to add it back to the front, so that I don't keep removing and adding the same item over and over again. That will just make the loop continue. So, and at every point when I'm done, I want to check my mean math. Now let me uncomment this, and so if I were to come and show us what our steps array is now, you see we have 4 4 4 4 4. So let's go over it again. At the beginning we have 1 or 2. In fact, I could decide to start from 0. That's how good this is. I could decide to start from 0 and you still be the same thing, because when starting from 0 it will still add. Maybe we start from 0. I think we start from 0. So we start from 0. At point 0, there's only one starting point, which is 0. So the minimum there is not. So if I show us what the minimum is here, the minimum is 0. It is not on our number of steps. And just for us to see, the number of steps we have is 4, but the minimum is what? 0. Okay, so our minimum is not equals to steps. So the minimum value is 0, and the number of steps is 4, so it's not. So we start, so we get our value. So I just want us to see what this looks like. This will not help us. Okay, this will not help us. But at the beginning, okay, let me do this. Steps array. Okay, and I'll put this here just to show us. Okay, so at the beginning it was 0, right? So if you look here, it was 0. So when we pop out, it becomes empty, because what pop will do, it will remove the last item, so which is 0 there. The only item is 0, so it removes it. Okay, so when it removes it, what does it do with it? It says if our value, if it's equals to the number of steps. So val here at this point, so what is val here? For in the first scenario, val is what? Val is 0, because that was the only item in our steps array, so 0. Okay, it asks the question, is this value equals to 4? Because steps is 4 here. Our steps in the question is 4. So is it equals to 4? No, it's not equals to 4. So it adds, since it's not equals to 4, it comes here. it's not equal to 4, it comes here. So it now says, okay, we add 0 plus 1 and we add 0 plus 2. So that means first will be 1 and second will be 2. So if first is less than or equals to the steps, then the steps is what? 4. So if this first, which is 1, is less than or equal to steps, we add it. So if I were to show us this, our steps array here, you see that at the beginning, our steps array is 1 and 2, because when we have 0 in beginning, it does 0 plus 1 and 0 plus 2. Both of them are less than 4. So it have 1, 2. It goes to the next one. 1, so 1, 2. It now comes back here. It pops out. So it remain at this point we have 1, 2 in our steps array. So you remember, if you come here and you ask what is the minimum value of for this, of course the minimum value at that first, for that will be at the first stage is 1 and 2 is going to be what? 1, and 1 is not equals to our 4. So we continue. So we come here again. At this point steps array is 1, 2. So pop, we take out 2. So if we remove 2 out, our steps array is just left with 1. Okay, so our value at this point is 2. Okay, so when we pick out 2, it says, is 2 equals to the number of steps 4? No, it's not equals to our number of steps. So we go over this again. 2 plus 1 and 2 plus 2. So 2 plus 1 is 3. 2 plus 2 is 4. So you find out that the next array is 1, 3, and 4. Because 2 has been 2 have added 1 and 2 to it. So we have 3 and 4. That's fine. So we go to the next. So if we check there, it's 1, 3, 4. So we come back again. We see we want to remove the last item in this. So what is the last item? The last item is what? 4. It comes there. Is 4 equals to 4? Yes. So what will that do? If you notice, it comes back here. It adds the 4 back to the front. That is what on shift will do. That is what I'm doing. Because if I add it back to the back, it means it will go back. So let's if I put this to be pop. Oh, sorry. If I put this pop, it will be an endless loop. It will always, so it will go pick up the item and remove the same item. It will just be removing and putting the same item over and over and over again. I hope that is clear. So that is why we have to use on shift, so that it goes on to order to pick another item. So that is why we are using on shift here. So it goes again, but when it is 4, so it comes back here. 4, it picks up 3 now. So when it picks up 3, it asks the question, is 3 equals to 4? 3 is not equals to 4. 3 is not equals to 4. Is 3 equals to 4? No. So it's not equals to 4. It comes here. 3 plus 1 is 3. 3 plus 2 is 5. Now so 3 plus 1 is 4. 3 plus 2 is 5. Now 4 is less than or equals to 4. Is less than or equal to the number of steps, which is 4. So it adds it. But 5, which is the second item, is not less than or equals to. So it will not add it to our array. So that's why you will not see 5 here now. So, and it continues till it has filled every possible value of as 4. So possible steps is 4. So step 4, 4, 4, 4, and that is when we come out of it. And so what do we do at this point? What the question asks for is the number of possible unique ways. So if you look, we have 1 way, 2 ways, 3 ways, 4 ways, and the 5th way. And if we look at our sketch pad, so this is 1 way, which will give me 4, another way that 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 will give me 4. So there are 5 ways we can get 4. So we just need to, the length of our array will actually be what we are looking for, and so that is what we want to return, and boom, we have it there. So if I were to just clean this up, if I were to clean this up now and just so we see the code, so this basically is it. So 5 steps. So let's just go through and just try and play with this, and let's, for 5 steps, for 6 steps, for 7 steps. Okay, then So 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7. Okay. So it's going to take a while. Sorry, my let me just comment this out and bring it back. So it's taking a while to process this. Okay. So let me put it back. So for the first step, there's only one way. If there are two steps, there are only two ways. Either you go one or you go two at once. For three steps, there are three ways, and I think this is correct. Now, if you look at these numbers, 1, 2, 3. So if you look at the numbers, we have 1, 2, 3, 5, 8, I think 13, 21. This follows a sequence which we call the Fibonacci sequence. So it means that this question can be solved using Fibonacci sequence. That I will leave us to go and check out. So basically, we could use Fibonacci sequence to just do this, and we will still get the same value, because the pattern is going through the Fibonacci sequence is that, and when the summation, so after we have our first values, Fibonacci says that the sum of, for instance, 3 is 1 plus 2, 5 is 2 plus 3, 8 is 3 plus 5, 13 is 5 plus 8, 21 is 13 plus, and it keeps going, and that is the sequence there. So if you look at it, that's basically it. So it follows this Fibonacci sequence, and we could use the Fibonacci sequence to do this. But you don't know this by just looking at the question. It's because we have solved it now, and we look at the pattern and we say, oh, it's following the Fibonacci sequence. But on the face value, it doesn't look like a Fibonacci sequence question. So basically, this is the one I put. In the next, we will just do the iterate. This is the iterative, so we'll do the recursive approach. We'll look at how we can use recursion to solve the same question in a maybe better way, maybe, but we'll look at solving this using recursion. Thank you, and see you in the next video.